Yes, as we finished the last day lesson, today we have to start our new lesson, which is using microcontrollers. I think you have received your Arduino kits. If not disturbed by this current situation or the lockdowns, for those who have ordered, I think you got the Arduino kits, right? But anyway, today I'm not going to do Arduino. So today I'm going to start with microbit, right? So please write down the heading, using microcontrollers, right? Using microcontrollers. Sorry, using microcontrollers. Okay, before we begin, I would like to ask, what is a microcontroller? What is a microcontroller? So as your knowledge, anyone would like to respond? A microcontroller in Sinhala you call Shudra Palaka. English microcontrollers. What is that? What is a microcontroller? Yes, anyone have an idea about microcontroller? No one. Okay, microcontroller is it's like a computer. It's like a single chip or single board computer. So that is wonderful, right? So using a single board, you can create a computer, or using a single chip, single microchip, single IC or very large scale integration, you can create a computer. That's wonderful. So that is a microchip, right? Okay, so let's go to the lesson in your syllabus. And that is this about the microcontrollers. Yes. Use of microcontrollers. And
sir.
Yes.
So have you uploaded the recording of
Last week?
Yes, sir.
No, I think there's a delay of uploading. Everything will be delayed around closer to 2 weeks or 3 weeks delay will be there. So the reason is that because some students, so we decided to delay that, because some students they only think to participate the recorded lecture, and the live lecture most of the students are skipping. So we decided to delay, keep a gap between that. Anyway, there will be 2 weeks delay, right? Don't worry, if you're coming to the live class you can catch it, but there will be 2 weeks or 3 weeks delay in the recording. Because some are like not coming to the classes, they later they watch the videos without coming to the classes. That is not good. Then you are not committed to learn. That will actually reduce your results. Okay, microcontroller. Microcontroller means, you can see here, there's a scenario. You can just read it out. So they were talking about automating this, automating of the light system. Whether you can automate this. That means, so you know that in the road lamps, sometimes I have even seen road lamps are not properly turning off. So sometimes in the noon also road lamps are lighting on status. So that is not good. It's wasting of energy. So they are discussing whether it can be automated. So similar to that, repetitive tasks. Road lamps, so we can automate these simple tasks. Automate automatically computer because these are repetitive tasks. Open in a door, close in a door when a visitor comes. So we don't need people to do that. Why we use people? It's kind of like, so it's wastage of energy, wastage of human energy. Because to open and close a door, we have to keep a person. To put a light and turn off light, we have to put a person. To lock a door and unlock a door, we have to keep a person. That is unnecessary. So we can automate it. Instead of people, machine. So most of the places, then travel kala තියෙනවනම් දැන් මෙතන ඉන්නවනේ වෙන රටවල ඇවිදලා ඉන්නවනේ සමහරු. නැත්නම් ෆිල්ම්ස් වල හරි ඔයගොල්ලෝ දැකලා ඇතිනේ. දැන් අපේ රේල් ස්ටේෂන් එකට ගියාම, අපේ ලංකාවේ රේල්වේ ස්ටේෂන් එකට ගියාම, you can see there's a guy to give the actually guy to give the ticket in the ticket counter. But normally, if you go to a closer country like India or Malaysia, some stations are there. So mainly the Malaysia, almost all the places. But India, some places are there, right? Bangkok. When you go there, so that is automated. There's a ticket machine, not a ticket person, ticket machine. Ticket machine. You can touch and select the destination, put money, and then change will automatically come. And you can get the token or the ticket. To check ticket also, ticket check-in is also done by a machine, because that is also repetitive. And so most interesting thing, drive-in is also done by a machine. It's auto drive-in train or driverless train, right? You can just Google it, right? Just Google it. Driverless metro train, and you can just see in the videos, right? Driverless metro trains. Just go through the videos and see. No driver is there, and no ticketing machine is there. Ticketing machine is also automated. Driver is also not there. Driver is also automated. Yes.
Excuse me, sir. Is that the MRT?
Yes, MRTs. So there are like these different terms for these projects, right? So this is driverless metro rails, right? Monorail is also something, right? And monorail is also some other. Monorail is here. Monorail, or this is not. This is MRT. This is not monorail. Monorail is also such project. Monorail dekala tiyena. This is monorail. Here also you don't have drivers. This is also automated, right? So it's going on top of the road. There's a different monorail track. There also you have this automation, right? So likewise, in future, you know, guys, in future you will have very few jobs. Why? Everything can be automated like this. Then godak me wage task automate karanna puluwan. Ticket dene ewa, ticket kadne ewa, ticket check karne ewa. Everything can be automated. You can automate your own home, smart home. You can automate washing, fully automatic washing machines are there, which can even dry your clothes, which can even iron your clothes. Fully automated fridges are there, refrigerators, right? And you can automate your home also. Home environment can also be automated. Many tasks can be automated, right? So your vehicle parking can be automated. Vehicle driving can be automated. Tesla has done that, and Google is also doing, right? So all these places, microcontrollers are used. So microcontroller means a single board computer, so which can automate many tasks, or single chip computer. Okay, under microcontrollers, please write down this note. Computers are supporting input, output, memory, process, storage, and communication operations. Communication operations. Microcontroller is a single chip or single board computer which also support input and output through inputs and outputs of analog and digital signals, input and outputs of analog and digital signals through pins. Through pins. Which has a memory, which has a volatile and non-volatile memories, which has a volatile and non-volatile memory. Volatile memory means it's like storage. Non-volatile means like random access memory. Volatile කියන්නේ current එක තියෙනකොට current එක නැති වෙනකොට නැති වෙන ඒවා එක RAM එක වගේ. Non-volatile කියන්නේ storage වගේ. So it has storage. So volatile it's RAM. Non-volatile storage. Memories. A processor or multiple processors. Multiple core processors. Input, output, memory, processor, and communication components. Those are used for automating repetitive tasks, and inputs are mostly captured using sensors. Sensor වලින් තමයි input capture කරන්නේ. Input දෙන්න ඕනෙත් නැහැ. It will automatically sense. It uses sensors to get inputs. සංවේදක පාවිච්චි කරනවා. කියන්නේ automatically යාට පුළුවන් temperature එක හොයාගන්න. Automatically it can find the gravity and speed of or motion or the velocity. Right? It consists of general purpose and special purpose analog, digital, analog and digital, input output pins, volatile memory, non-volatile memory, volatile memory, non-volatile memory, processor, system clock for synchronize, system clock for synchronizing, and communication devices. Communication interfaces. Okay, that is about the microcontrollers. A short note, everything is there in the book. I'll read it out for you. But so this is the summary note. Right, okay, until you write, I'll explain the book. Until you write this, I'll explain the book. You can go through this quickly. I'm going to explain the book. Right. Okay, hopefully you are doing right. You can listen now. Right here, you can see the processes happen, input and process output. That is similar to information system. We learned that previously. Here, it will take input from the sensors, process and produce outputs. These are mostly, these outputs and inputs are tangible. You can see physical. These inputs and outputs are physical, not like, unlike computer. Computer inputs, like, it's not like physical. No, you can just move the mouse, type using keyboard. That's the only thing. But this can sense light, humidity, temperature, rain. Maybe it can sense the time. And based on that, microcontroller is like producing some lights, maybe sounds, doing some automating tasks like moving, actuating. Those are the things done by these microcontrollers. And this is like a chip. This chip has everything: CPU, memory, and system block, peripherals for input output. You have peripheral component connectivity, right? So these are the places: solar lamp, washing machines, ovens, and it can be single board computer or single chip computer. Now you have to write examples. So single board, example, you can say Raspberry Pi is example for single board computer. And single chip computer, you can say Arduino. Arduino. And these are some example: microbit, Arduino, Raspberry Pi. Today we are going to learn about microbit platform, right? This one. Okay, finish writing first. First finish writing, then I'll explain this. Right. So this is what we are going to learn today. This is microbit 1. So similar to the one you got, but microbit, it has more LEDs. In your Arduino one, only one LED is there, no? Arduino ke one LED ekai thiyen. Here microbit, you have LED grid. How many LEDs? 1, 2, 3, 4, 5. 5 by 5 LEDs. 25 LEDs are there. And it also has like switches which can be programmed. These are the switches which you can program. And these are the inputs and outputs. 1, 2, 3, likewise you have input, output. And this is to give the power, 3-volt current. And this is to ground, because the power come in should go out. So this is to power in and power out, ground. Okay, the other side of the board, you can see. So this is a special antenna for Bluetooth. 6. Yes, Bluetooth smart antenna. And then you have USB connector. USB connector. This is the chip. This is the chip in the microbit circuit. This is by BBC company. And you can see 9. 9 is to give the power. 3-volt current ekak denna thama 90 to give power. And then you have this connectivity pins, 11 pin edge connectors, connectivity pins. And you have special sensor, accelerometer and compass. Dishaව හොයා ගන්නයි. හරි මේ process එකකුත් තියෙනවා, accelerometer එකකුත් තියෙනවා, compass එකකුත් තියෙනවා. Right, see the size of compass. මේ තමයි තියෙන compass එකේ ප්‍රමාණය. මාලිමාව. ඒතර accelerometer එකෙන් වේගය හොයා ගන්න පුළුවන්. එතකොට ඔයාලට මේක high කරන්න පුළුවන්. car එකකට හරි මොන හරි යන දෙයකට high කරන්න පුළුවන් to find the speed. And the compass to find the angle. Okay, let's see. Let's create. So you can download microbit. So if you have this board, my board එක තියෙනවා USB වලින් connect කරලා you can download microbit software to code this. So how many of you are having microbit in your schools or in your home? Anyone? කාගේ හරි ළඟ තියෙනවද? Microbit module. This is costly, right? So you can just see microbit module, and let's go to Daras. And search for microbit module. You can order to your home, right? Microbit kit will be, yeah, this is the kit. The cost is around 5,000. Yes. So with this other components, it will be like 17,000 with the chassis and all. Chassis, Bluetooth sensor. It's like too much, right?
Excuse me, sir.
Yes.
Sir, is microbit better than Arduino?
Cannot tell like that, but microbit has like inbuilt sensors and costly. Cost is high. You cannot say it's better than Arduino, so you have to compare the processing power, right? So it depends on how you code and the purpose that you're using. So you don't need LED, this component inside the board, no. Arduino, you can separately connect that. In separately, you can connect LED tree. So Arduino is general purpose. You can scale it. But here everything is together, comes together. So actually, easy to code. Microbit is easy to code than Arduino. Okay, to code that, I'm going to use this one, virtually code this. I'm using this to virtually write the codes. Okay, I'll send the link to you. Please bookmark this, right? May mama evana links practice karan. Please go here. So then, since we have done what this, we have already done stretch now. So this is similar to stretch. You can automatically do something. You can write the codes similar to stretch. Okay, let's take a new project. Okay, so please open this and I'm going to code it. There's another one. So this is also very good interface. This is called Tinkercad. Tinkercad is also very good one. You can either use Arduino, or here this is the Arduino board in Tinkercad. You can give the power and like. So how many of you got the Arduino board?
I
Can
have,
you
sir.
raise the hand? Raise your
I
hand.
have, sir.
Okay, raise your hand, please. Dimat, okay. 2, 3, 4. We sent more than 4, 5. We sent around 12, 10, 12. So who got that then? Right, maybe some other grades, right? Okay, 6. Right, okay. Lower your hands. 6 of you having this, but others, you can still use the virtual one. But I still prefer use the physical one. Physical one use කරන්න පුළුවන් නම් නියමයි පුතේ. මොකද එතකොට අර ඒ අත්දැකීම එනවා. මේ virtual එකටත් පුළුවන්. Virtual එකටත් පුළුවන් එහෙම කරන්න. ඉතින් ඒ වුණාට ඊට වැඩිය physically පාවිච්චි කරද්දි හොඳයි. දැන් LED bulb එකක් අරගෙන මේ LED bulb එක අපි just let's connect කරමුකෝ. අපි මේකේ pin එක anode එක connect කරමුකෝ, plus edge එක to pin 13 and then yes 13, and let's connect the other end. Ground it, cathode, let's ground it. Okay, this is not a very good setup, but 13 is by default there's a LED blink program which is written to 13, and when you switch on this, sorry, when you switch on the simulation, you can see LEDs blinking. මේ LED එකෙන් පෙන්නන්නේ තෝකම තමයි. ඒක අපිට වෙනම LED එකක් මේ විදිහට ගහලා blink කරන්න පුළුවන්. You can try this, right? Not now, later. 13 is for the positive. අර දිග edge එක, දිගින් වැඩි එක තමයි anode එක. In LED, the longer edge you can connect to 13 and the shorter edge you can connect to ground. And it should work like this. Before writing a code, right? But here, actually after writing the code, so this is the code, right? This is the code. LED high, wait 1 second, LED low. Let's change this to 0.3 seconds and 0.3 second here. Now when you run, let's run this. Okay, now you can see it's more faster, right? It's blinking more faster. 0.4 seconds, 3 seconds. And this is the code. You can see the code also. Not this code. Arduino IDE එකේ තියෙන මෙන්න මේ code එක. Not the block based one. You will see the other one. The blocks. code here. Code, you will see this one, right? Text. Let's go to the blocks and text. Yeah, you will see this one in your Arduino interface. This is how you write the code to the 13 pin. Right? Anyway, so Arduino I'll teach later. First of all, let's go to the other one, microbit. Microbit උත් මේකේ code කරන්න පුළුවන්. ඕන්න. මේ තියෙන්නේ microbit එකක් තියෙනවා. Microbit එකත් අරගෙන මම Arduino එක අයින් කරලා දාන්න. You can take the microbit one and remove the Arduino. Okay, I don't need this LED too. And here, so you can just connect this. The adapter will be connected here. මේකටත් අර වගේම you can give the 3 volt ground and you can take inputs outputs and start coding. You have few inputs, right? අරගේ input ගාන වැඩි. මේකේ input output ප්‍රමාණය අඩුයි. You have 1 2 3 and 2 switches A and B which you can program. Okay, so first let's write the code for a default board. So today we are going to discuss microbit. You have Arduino also. So initially we have to discuss microbit, and in the latter part of the book you have Arduino. Here you have both. More priority.
Excuse me, sir.
Yes.
So is there an offline editor for microbit?
Yeah, you can download offline editor for microbit from the same site.
Okay. Okay, sir.
Right. Okay, let's run small code here. So this code is similar to quite similar to the previous block style code in Scratch. එහෙන් දෙත අමුතුවෙන් ආයි කියන්න දෙයක් නැහැ. ගොඩක් ඒවා same. හැබැයි ඊටත් වැඩිය lazy මේක. Right? Okay, let's see how to write a code here to microbit. I'm going to write my first code. So now I hope everyone open this editor, right? The second editor is this. I'll send it later. This is for, okay, choose another folder, and I'm going to create a new folder. New folder should come to here. Bookmarks bar, new folder, and this is for grade 9. Save. This is also for grade 9. Okay, I hope you have opened this. Right, then, so I'm going to select the basic, and from that I'm going to get this forever. I want to repeat this forever. And from the basics, again, I'm going to take a LED tree. That is this LED tree, right? Then I'm going to run a code like this. I'm going to keep this one like, okay, let's say, let's draw like this. Okay.
How to get that microbit interface?
I have sent the link already.
No, sir, the website is open, but the microbit picture is not there.
See.
Yes, sir.
Can you refresh?
Okay.
It takes some time to load, right? So if you have network connection delay, it might be because it will take some time to load this. Here still in my one also loading. Now only it get loaded. It will take some time. You have to be patient. Because even I'm using fiber connection, but still it takes some time. Right, okay, let's write like this, and I'm going to draw something like this. And now you can see here, you can see letter A. The LED bulbs are like, you can see it's light in like letter A. I want to blink this, so I'm adding another one. So I can blink. Forever, show LEDs and show LEDs blank.
Excuse me, sir.
Yes.
So I can't see the circuit.
In your one. Or in my one.
My one.
Please wait a little. ටිකක් වෙලා ඉන්න වෙනවා
Can
load
see,
කරලා.
So it says the web page is not
Then I
there.
can see.
Hiruka, what it says?
Now we can see, sir.
Now you can see, right? Web page is not available. එන්නේ පුතේ connection එක ගොඩාක් slow වුණාම ඒක එන්නේ. Try it again and you will be able to load, right? Try it again and you'll be able to load that. Okay, now you can see I have added this. So please go to the basic and get this forever, and then go to this LEDs and get the LED 2 times. The first time LED is lighting like this, the second time LED lighting is nothing. So when you run this, you can see it's blinking letter A. Blinking letter A. Try to get this project. Try to do the project. If it is not loaded, it's okay. If it is loaded, you can try. If it is not loaded, you have to write. Patiently wait. You were seeing in another. So next day, try to download that. Right? And open. Then that පොඩ්ඩක් බලාගෙන ඉන්න. Load වෙන්නේ නැත්තම්. Right, everybody finish?
Yes, sir.
Okay.
Yes, sir.
The next challenge is I want to display. Okay, this is the first challenge. First challenge is a blinking letter. Right. I'll add that to the note. The second challenge. So try to show numbers from 0 to 9. Try to show numbers from 0 to 9 using the microbit circuit. Use the microbit circuit and try to show numbers from 0 to 9. To do that, you can use some other controller. So 0 to 9 පෙන්නන්න පුළුවන් මෙහෙමත්. You can change this to 0. Let's say this is 0. I'm going to turn on and on. Okay, this is 0. Then 1 maybe there. Let's say 1 is this. This is my number 1. 0, 1. Then 2, I'm taking another one. But this is heavy, right? මෙහෙම ලිව්වොත් එහෙම ඉතින් එපා වෙනවා. කෝඩ් ගොඩයිනේ. This is 2. This is number 2. Now you can see 0, 1 and 2. එහෙම ලියන්නත් පුළුවන්. 0, 1, 2, 0, 1, 2, 0, 1, 2. But this is heavy. මේක දිග වැඩි. ඒ හින්දා මේ වගේ දෙයක් කරන්න පුළුවන්. You can remove this. And you can show, you show number 1. It's easy. Show number 0. Then show number 1. Then show number 2. There is another method. Show number 0, show number 1, show number 2. Now also it will display. Yeah. Zero, 1, 2, okay, 0, 1, 2. Still it displays. But you have a easy method of doing that. What is that? මතකද loops කියලා එකක් තිබ්බා. Repetition. Right? Repetition, you can just show, you can use a variable rather than using like this also. You can use a variable. And that variable, let's say, create a variable. Make a variable, and I'm going to create variable number. Okay. Then I'm getting this set number to 0. Set number to 0. After displaying that, I'm changing number to number by 1. Starting from 0, changing by 1.
Excuse me, sir.
Yes.
What is the name of the variable?
Number. I have used number. Created a variable called number. Okay, then let's start like this. Forever, I'm going to change number by 1, and I'm going to start from the number 0, change in the number 1, and I'm going to show the number. Show the number from variables. I'll drag the number and keep it here. Okay, let's see. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it's going more than 10. So you have to stop that. No, I need only 10 times. So please go here and then only repeat 10 times. Only repeat 10 times. Starting from 0, just repeat 10 times. Now let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 0. Back to 0. After the 10th, it will come back to 0. 0, like 1, 2. After that, it will come back to the 0. Okay, this is another way of doing that. Right, you can try this one. Just give a try to this one. And your code will be automatically generated in JavaScript. Here, this is the JavaScript code. It will be automatically generated. And this is the block code. Try it and let me know if you have any difficulties. I'm still using the built-in LED. The LED එකම තමයි මම use කරන්නේ, not a new circuit. I have not created any new circuit. I'm using the existing microbit circuit and doing this. If you have any doubt, please ask right. මොනවා හරි දෙයක් තියෙනවා නම් අහන්න තේරෙන්නේ නැති